Okay, now we're going to be given two lines and we want to see if they intersect. So the first thing we want to check is to make sure the lines aren't parallel. So we know by the form of these equations, okay, this is just a parametric form of the equations, we can tell a point on the line and we can tell a vector that's parallel. So we know that a line parallel to line 1 would be 3, 3, negative 1. I'm just taking the coefficients of the vector t because I can see that this would be 2, 0, 1 plus t times 3, 3, negative 1. So that would be, that standard form of a line, the vector form for an equation of a line, or look at it as parametric equations. So this is the vector parallel to line 1, and we know a vector parallel to line 2 will be the coefficients of the s. So 2, 3, negative 2. Okay, so we can see that V1 is not a constant multiple of V2. So V1 is not parallel to V2. Okay, so if they were parallel, then we would have that they were going to intersect or possibly be the same line. So now what we want to do, though, just because two lines are parallel in R3 doesn't mean that they don't intersect. So we've got two lines in space, and we're trying to see, let's see, you could have one totally below the other one and still not intersect. Okay, so what we want to do now to see if they're going to intersect is to find, is there an S and a T where the X's, the Y's, and the Z's would all be at the same point? So we're going to assume that there might be a point of intersection and see what would the S and the T be where that intersection occurs, because we can't expect the parameter to be the same for each of the two lines. There might be a certain t value when it's at a point and a different t value where it's the same point. So find where x, y, and z are equal, for different s's. So we want to find s and t where the x's are the same. So we're going to set 2 plus 3t, that's the x for line 1, and it has to equal to 4 plus 2s. We want 3t, that's the y coordinate for the first one, to equal to the y coordinate of the second one. And then we want 1 minus t to equal to negative 2s, the z of the third one. So if we can find s and t that make these three equations true, then they'll have a point of intersection, and we'll know exactly what the t values or s values are, the parameter values are for each of them when they arrive at that point. Okay, so let's just do elimination. So I'm just going to take equation 1 and I'm going to subtract equation 2. So I'm going to have equation 1 minus equation 2 would be 2 equals 7 minus s. So that tells me then that s is equal to 5. Well, if s is equal to 5, I can get from equation 2 that 3t has to be minus 3 plus 15. So that means that t is equal to 4. Okay, so that means if I plug in s equal 5 and t equal 4 into the first two equations, let's see, t equal 4 in the first equation will give me 14 on the left side, s equal 5 on the right side will be 14, s equal to 5 on equation 2 will give me 12 on the right, and t equal 4. So equations 1 and 2 are satisfied by these two values. But for all three coordinates to have the same value, we also have to make sure equation 3 is satisfied. Equation 3 for these two values has that 1 minus 4 would have to equal to negative 2 times 5, and that is not true. So that means all three coordinates are not going to be the same at the same, for each one of the two lines. So that means there is no intersection. Now, when you have three equations with two unknowns, you can usually get a solution for two of them, but you have to make sure all three are satisfied if you want all three conditions to be met. Intersection. Now, two lines that are not parallel and don't intersect are called skew. Okay, so these two lines are skew. Okay, they don't intersect and they're not parallel. Okay, let's look at the second example. Again, we want to see first, are they parallel? So a vector parallel to line 1 would be 1, negative 1, 3. And then line 2 would be 2, 2, 4. And again, we see that one's not a multiple of the other, so these two lines are not parallel. So now let's see if they intersect. To intersect, the two x's have to be the same for some s and t. The two y's have to be the same for the same s and t. And the two z's have to be the same for some s and the same s and t. Okay, so now let's see if I take equations 1 and 2 and add them. So equation 1 plus equation 2, call this one 1, 2, 3. Adding those two equations, I get that 7 has to equal to negative 1 plus 4s. So that means that s is going to equal to 2. Plugging in 2 into the second equation, I'm going to have 4 minus t is negative 1 plus 4. And so that means that negative t would equal to negative 1, so that means that t would have to equal to 1. Okay, so now just checking equation 1, t equal 1, s equal 2, I get 4 equal 4. Equation 2, I get 3 equal to 3. Now the whole thing is, does equation 3 also get satisfied for these two values? And so checking, we'll have 5 plus 3 times 1 equal to 4 times 2. And that is a true statement, so these two equations do intersect. Now, where's the intersection point? Well, the point they intersect at is the x, the y, and the z for those given s and t's. So we know that s equal 2 and t equal 1. T equal 1 and line 1 will have the point x equal 4, y equal 3, and z equal to 8. S equal 2 in line 2 will be x equal 4, y equal 3, and z equal to 8. So the point of intersection is 4, 3, 8.